Today's video will demonstrate the factory design pattern. Hello, I'm James Helfrich. In most scenarios, it's easy to create a new object. Just create a local variable or use the new operator. However, sometimes, especially with a large inheritance tree, it can be non-trivial to generate a new object. This video will demonstrate the factory design pattern, which allows us to easily create a new object. We'll begin with the definition of the factory. The factory design pattern is a function or method used to instantiate the requested variation of an object. So first of all, we take the client, and the client is going to give an object identifier, usually an integer, sometimes an enumeration, could be something more complex, to the factory function or method. And the factory function or method will then return the object. And this, of course, is a data flow diagram. Now, the factory facilitates creating objects that are members of a polymorphic set. So for an example, let's say I have a collection of different types of Porsche 911s. I have the Carrera, the Turbo, the Targa, and the GT2 RS. Now I want to create a new Porsche 911 because, well, let's face it, who doesn't? So how are we going to do that? So I'm going to start with an enumeration of different models, the Carrera, the Turbo, the Targa, and the GT. Then I'm going to create the factory function. And this takes a model as a parameter, and then it's going to switch based on it, and it's going to create a new Carrera, Turbo, Targa, a GT2 RS. And it's going to return that new object. How do I implement it? Now I'm going to integrate this in my program by, instead of saying new Porsche Carrera, GT, whatever, then I'm going to say factory, and then I specify the model, which is Carrera or the GT. And this makes it really easy to instantiate a new object of that type. Here's an example. A drawing program allows the user to place various objects on a canvas. This could be a dot, a line, a rectangle, a triangle, or an oval, or really any number of things. The canvas can contain any number of shapes and in any combination. This is a good candidate for the factory. Well, because if I say new dot, new line, new whatever, then I'm going to require the client to be aware of all the specifics of those different classes, including the derived class name as well as its parameters. On the other hand, I could have a shape factory, and then I specify the shape type, which is a dot, a line, a rectangle, triangle, whatever, and then I can create the object using the new operator and any non-default parameters that are required for the constructor. Here's another example. Consider the game of chess. I want to create chess pieces, put them on the board, but I also want to handle promotion and things like that. Once again, this is a good candidate for the factory design pattern. We can certainly create the pieces with new, but that requires the client to know many more details about the derived class than is necessary. So to give you an idea, a board has 64 pieces, and each piece can be a space, a pawn, a knight, a bishop, a rook, a queen, or a king. So how am I going to make this happen? Well, let's take a look at some code. Okay, first I will create a piece type, and this is an enumeration of a space, a king, a queen, a rook, a bishop, a knight, or a pawn. And then at the bottom here, I'll create a factory. And this factory will take a piece type as well as the location where it goes and whether or not it's white. And what does that factory look like? Well, once again, I take the piece type and then my location, and then of course, whether I'm white. And then I'll have a big switch statement based on my piece type. And then I'll new a space, a king, a queen, a rook, a bishop, a knight, or a pawn. Now observe that these different constructors take different parameters. The space, for an example, does not take whether I'm white or not. And so the client should not have to be aware of that implementation detail. Well, how are we going to integrate it? So in my reset board, I'm going to call factory space, factory pawn, factory rook, bishop, knight, stuff like that, and of course my black knight. Notice how the board class, specifically the reset method, doesn't have to know anything about the specifics of the pawn or the knight or the bishop or the queen class. I'm abstracting that away. The same thing also works with promotion. Since my move.getPromotion tells me which elements can be promoted, then I can just call the factory on that element and a new queen or bishop or knight or rook will get created. The alternative would be to do it another way, where I have to have a switch statement here and then call the correct constructor for each one, which is far more tedious. Let's take a look at another example. I want to create an orbit simulator, and this orbit simulator has a wide variety of different satellites, each orbit the Earth. And of course, when two satellites collide, they break into parts and fragments, and I want to be able to model that as well. Okay, so notice I have a lot of different satellites that are orbiting, and each one has a different orbit and has different properties. And now let's say I want to shoot the Hubble. Why would someone want to do that? It's going to break into different parts, and including my own ship as well. So this is the class diagram for Orbit Simulator. Notice how the simulator has many satellites, and the satellite can be many different types: a projectile like a bullet, a fragment, a whole, which is a Hubble, a ship, a Sputnik, or a GPS, or a part like a GPS center, GPS left, right, or a whole bunch of other different ones, as well as the Earth. So how do we make this happen? Well, when I destroy the Hubble, it's going to create a telescope, a computer, the left and the right antenna, using the new operator. These are the different parts. And of course, when the right part gets broken up, it's going to create two fragments, or when the left part gets broken up, it's going to create two fragments, or when the computer or the telescope itself is going to create a collection of different fragments, four of them in this case. And here I have to use new for every time I instantiate a new object to add it to my satellites collection. There must be a better way. So the first thing I'm going to do is, in my satellites, I'm going to create an enumeration of different types of satellites. Okay, now that I've done this, now I'm going to create an actual factory method, which will generate a new satellite based on the type. So when I'm finished, my factory will have all the different types of satellites. And also notice how, like, the different constructors, like ship only has a default constructor. The GPS satellite is going to have a satellite and a direction, where the GPS whole is going to have a degree divided by 360, because it's going to be an index of 0 through 5. And so all the different parameters for the constructors are going to be abstracted away, so the client doesn't have to know about that. So the non-factory version calls new, new, new. The new factory version just calls factory and enumerates which factory type, which greatly simplifies the entire process. This is example 39.2 and the factory section of the object creation chapter of the software design textbook.